Today's video is going to be slightly different from previous ones. Today our experiment will not be a physical one attempted in real life. It will in fact be a simulation that I've written in Python. It's only a simple simulation, but it includes balls that can fall under gravity and have something called the coefficient of restitution, which enables them to bounce back again. It may only be a basic simulation, but it does produce some pretty fantastic results. We begin with the simplest scenario, a perfectly elastic bouncing ball, and we can change it to make it bounce more realistically. We can also compare the behaviour of different balls by lining them up in increasing bounciness. It looks like there might be a pattern here, so if we increase the number of balls and try again, maybe we can spot it. And then the pattern becomes obvious. Waves form that then ripple across the screen. If we add a permanent trail to the balls, then we can study how the maximum heights vary. Let's see if that brings up any patterns. And it does provide a new pattern for us to explore. This pattern is here because the maximum bounce height is proportional to the square of the bounciness of the ball. Then if you randomize the bounciness of the ball, which is known as the coefficient of restitution, you end up with a pattern from the start of the video. If instead we keep the coefficient of restitution the same for each ball, but instead change its gravity, then we can study how gravity affects bounce height. And you'll notice that if we have the balls arranged in increasing gravity, we end up with a very similar pattern from before, but to the other side of the screen this time. When we turn the trails back on, it becomes immediately obvious that the bounce height is not affected by changing gravity. And at the end, we can just randomize everything and admire how pretty it looks.